Do you like fighters or spacecraft design? Grab your copy of the first Spacedock reference book all about these topics on our Patreon through the link in the description and pinned comment below. Hello everybody and welcome back to Spacedock. I'm Hujuana and today's topic is yet another look at realistic weapons you can use in sci-fi, though this time it's a bit less viable in this regard despite its popularity. I am of course speaking of plasma weaponry, which shows up everywhere because it sounds reasonably high-tech without stepping into the realms of magic. It's also exotic enough to instantly set apart an alien faction from our own, such as Halo's Covenant, who use it as the bedrock of their weapons technology. But is plasma really viable for use as a weapon? And what even is plasma?
We just don't know.
Get out of here, bird, we do know, and we know very well what it is. Plasma is the fourth fundamental state of matter. The other three I'm sure you're fairly familiar with, but just in case you're a cross-dimensional visitor to our universe, we have solids, where atoms are closely packed together and they cannot freely move. The next is liquids, an incompressible state where atoms can move around and conform to the shape of their container, and then gas, a compressible state where atoms move around, conform to their container, but also expand to fill it. Plasma is kind of similar to gas in that its constituent atoms are free to move around and expand to fill containers, but a lot of those atoms have had their electrons ripped off, which then also freely swim around with the atoms they came from. This makes plasma electrically conductive and very sensitive to external electromagnetic fields. It is also the most common state of matter in the universe. It's everywhere. Stars are made from it. Even what looks like the empty space between planets, stars and galaxies is actually full of plasma. Relatively speaking, it's still a vacuum. Even down here on Earth we can see it in natural phenomena like auroras and lightning. Even fire, if it gets hot enough, can be made from it. And we use plasma all over the place in technology. Fluorescent lamps, neon signs,
bombs,
certain types of welding or cutting torches, and those funky ball thingies with glowing tendrils inside them. It's used all the time in electric spacecraft propulsion for both current and future missions. But as for weaponizing plasma, it's a lot less viable compared to the other realistic weapons we've looked at before, but it is possible. First off, if you want to get really basic with it, there are Cassava howitzers, those long-range nuclear spears I talked about in the nuclear weapons video, and their projectile is made of plasma. There is also the option of using an extremely hot engine that spits out plasma to melt things, but both of these are probably not quite what you conjure in your mind when you think of plasma weaponry. Instead, you probably think of blobs or bolts of glowing energy, travelling slow enough to be easily seen even at short range, and causing burns or explosions when they impact, or even outright disintegrating things. Real blobs of stable plasma like this are called plasmoids, and it is entirely possible to shoot them at stuff thanks to plasma's high conductivity, which makes plasmoids perfectly viable railgun projectiles. Yes, that's right, plasma railguns, which are actually a fairly common component in fusion research. One of the more famous examples, and one of the only ones that was looked at as a potential weapon, is the magnetically accelerated ring to achieve ultra-high directed energy and radiation, or Marauder for short. How long did they spend coming up with that acronym, I wonder? Marauder fired plasma toroids at thousands of kilometers per second, which not only caused mechanical and thermal damage, but also a blast of electromagnetic radiation as well. Since then, the idea of weaponizing plasma railguns seems to have not been pursued, possibly because it required an ungodly amount of power to function. As for being used in space, plasma weapons have a bit of a catch. You see, on average, space is empty. Remember what I said about plasma expanding to fill its container? Well, space as a container is an exceedingly large one, so plasmoids in vacuum would expand very quickly into basically nothing, which makes the usual sci-fi portrayal of plasma weapons fairly non-viable. Cassava howitzers get away with it by having an extremely high velocity bit of plasma, so it hits its target before expanding too much. As for standard sci-fi plasma weapons, the way they get around this expansion problem, if they even consider it, is to have some way of containing the plasmoid as it travels. This usually ends up being some electromagnetic field it's wrapped inside of, making use of the special properties of plasma that allows it to be influenced by these fields. There's another problem here though, as realistically, plasmoids cannot be contained by a field or charge from within itself. They need external containment. So a plasmoid inside a gun or engine or whatever is fine, but as soon as it steps outside into vacuum, it starts to rapidly expand. But sci-fi plasma weapons are not just used up there in the black, and can be found just as commonly in atmospheric use. For example, there is Babylon 5's PPG. These are small-scale plasma weapons taking the familiar form of pistols or rifles, used on spacecraft and space stations because they do not penetrate dense materials, and so cannot put a hole in a critical system or the side of the station. Is this how real plasma functions in an atmosphere? Sort of, yeah. But as ever, there are complications to be considered. Firstly, a plasma that is powerful enough to be flung around in big glowing bolts of plasma would almost certainly be higher pressure than the air around it, and we're right back to the expansion problem again. But if we switch to low pressure plasma, it unfortunately won't be able to hold much energy in each blob, so it needs to be fired in a continuous stream like a flamethrower. This constant delivery of energy can absolutely burn a target, and is essentially a weaponized long-range plasma cutter. Except, again, this probably still won't work. In fluids like atmospheres, hotter things are less dense, so they rise up over colder things. This also applies to our plasma cutter thrower, which you can visualize as being a stream of hot air. Rather than arcing downwards due to gravity like a stream of burning fuel, it would likely arc upwards, as well as being pushed around by air currents. However, in a zero-G environment, the stream would keep going forward until air resistance or air current stopped it, where it would just ball up, much like how a zero-G flame does. There is a potential way around these issues though, which is making use of vortex rings. These are pretty neat things that can remain fairly stable as they travel, but you'd need to be firing off a whole lot of them to match the energy delivery of the plasma cutter thrower from before, and hope that vortexes that close together don't all mix each other up into a big swirly mess while doing it. So plasma is awkward in atmosphere, but may have some ways around its problems. Surely there has to be something that can help out in vacuum. Well, I am pleased to say that there is, but it does shift the typical appearance from the plasma blobs that you know and love into the realm of beams, which you may also love. This is done by confining the expansion of those pesky little plasmoids along one axis. It still expands as physics says it should, but in a controlled manner that leaves it depositing all of its energy in one spot to efficiently cause damage. This is done by using a charged plasma and sending an electrical current running along it. And this whole thing is named a Z-pinch, so called for the Z-axis on a three-dimensional graph. The pinch confines expansion to the Z-axis, Z-pinch. Small side note, if you're into realistic future space tech, you may have heard this term before in relation to fusion engines, which I'll be covering in a future video, so subscribe now for that one. As for the pinch plasma weapon, with some technical fiddling around with electrical currents and yet more plasma, we end up with what is very similar to a particle beam. A beam that looks somewhat like a dead straight lightning bolt zapping from the firing ship to its target, with much the same damaging effects. So it is possible, sort of, to have realistic plasma weapons, but they have so many caveats and drawbacks that they may just not be viable compared to other realistic weapon options. But you know what? If you want to use them for your own creations that are otherwise realistic, then use them. As I've said before, realistic sci-fi is not better than non-realistic sci-fi. Want to make a fusion torch ship that flings plasma toroids to burn off the armor of its opponents? Want to mix in plasma grenades for your spacesuited troops battling over a moon? Please do so! Ultimately, it is your creation. You make the rules for it, and if you really want plasma weapons, you can make it work. Thanks for watching. You can support the creation of videos like this by joining our Patreon, where you can get a copy of our Spacefighter design reference book. You can also support us here on YouTube by becoming a channel member or by giving us super thanks. Thank you to our supporters, and I'll see you next time.